All right, these are the slides on the periodic table. So just remember that in these videos, there are two codes. One will be a written code that will come up on the screen. The other code will be a verbal code said by myself. Each code will be 3 numbers, and you will need all the codes in order to move on with the homework assignment. So when you are writing, when you are looking at these slides, or watching these videos, write what is in green. That information is like the important part. You can bullet that information, the bullet points, to have a nice, concise idea behind what we are learning. So this is the weekly review written code. I would recommend you write this down somewhere. So the question is, how is the periodic table organized? So if we look at the periodic table is a catalog of all known elements in the universe. It organizes the elements by chemical properties, atomic number. All elements have their own unique symbol. They consist of a single capital letter. So you can see that the atomic symbol, this is molybdenum, MO, but it is only one capital letter. Now, the elements in the periodic table are placed into one of 3 categories. You have metals, nonmetals, and metalloids. So you can see here the metalloids, this is called the staircase. You can see that these are going to be, this is just like how these elements react to certain things. So those are going to be the metalloids. Everything to the right of that staircase or the metalloids is a non-metal, but you can see that hydrogen over here is a non-metal as well. Hydrogen is technically like it's sort of in its own like category, but they put it with non-metals and in group 1. So yeah, and then everything else is a metal on the periodic table. So if we organize the periodic table even further, if we look at groups go up and down. There are 18 groups. Elements in the same group have the same number of valence electrons. So, which means they have the similar chemical properties. So if you look here, there are 18, right? And these are written on there. You can kind of see they're a little bit small, but 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 18. Now, if we look at 2 atoms here, right? So I have sodium and I have potassium. You can see here sodium is Na, potassium is K. They are in the same group. So that means they have the same number of valence electrons. And if I look at sodium, yep, there's 1 valence electron. If I look at potassium, yep, there is 1 valence electron there. So they're going to have similar chemical properties, which means these are very reactive because they only have that 1 valence electron. Now, periods go left to right. Those are the rows. There are 7 periods. Elements in the same periods have the same number of electron orbitals. Now, they do not have similar chemical properties. So if we look at these two here, we have sodium and argon. So sodium, looking at sodium again, is it's in period 1, and group 1, but it's in period 3. And if I look all the way over here to argon, argon is in period 3 as well. So they have the same number of orbitals. So you can see here I've got 1, 2, 3 orbitals for sodium and 1, 2, 3 orbitals for argon. But sodium, like we already established, has 1 valence electron. And argon has 8 valence electrons. So sodium is very reactive, but argon really isn't that reactive at all. It doesn't really react with anything because it has those valence electrons. Now, in this, I did have what you can do is you can color code your periodic table. So what you can do is you can color the metals, the non-metals, and the metalloids. So color the metalloids first. So that would be these green ones. And some places, polonium and astatine, those are labeled as not, they aren't metalloids. But in this case, we are going to consider them metalloids. I do have the ones that are listed out there. Now, the nonmetals are elements to the right of this stair step. So that would be the yellow ones. And the metals are the elements to the left of the stair step. So that's everything else. But as you can see, remember, hydrogen is its own separate little group up there, or its own separate little thing. Then I had you label the group. So we know that group, we sort of established between the metals, metalloids, and non-metals. but now certain groups have different names, those columns. So group 1, those are the alkali metals. Those have 1 valence electron. Group 2, those are the alkaline earth metals. Those have 2 valence electrons. Now group 3 through 12, those are called the transition metals. Now, we're going to skip 13, 14, 15, and 16 for now. Those do have specific names, but they're not really used that often. Group 17 are known as the halogens. So they have 7 valence electrons. So they only need 1 more valence electron to complete that orbit. And group 18 are known as the noble gases. So that's the 18, and they have a full valence shell. They don't really react with anything. And those lower 2 rows, those are called the inner transition metals. So if you look closely at that periodic table, it goes, you can see it goes 55, 56, 57, then it skips all the way to 72. Well, in between that, those are those inner transition metals. And on most periodic tables, those inner transition metals are taken out and put below that periodic table. That is how this is what your periodic table should look like. It'll be nice, it'll be color coded, and it has all those groups labeled. So at this time, I'll go ahead and give you the verbal code. The verbal code is 815. I say that again, the verbal code is 815. All right, so the question is the periodic table complete? So you might have seen on some periodic tables there are some blank spots or some placeholders at the very bottom, but it does end at 118. So yes, we did complete the 7th row. That sort of limits the amount of the electrons that can hold it. So as far as we know, we have completed the periodic table, but physicists think that there could be other periods below that. But we're always discovering, we're always learning more. We're always discovering more. We're smashing these atoms together in like particle accelerators, and we are seeing what happens. So that's how those last few were created. So in order to reinforce this, we did the periodic table class activity, which you had to identify like the symbol, classify it as a metal or metalloid, or there's a lot, and like what that means. So there's a lot in that video that reinforces going over the periodic table. And last thing, what do you do with a sick chemist? Well, if you can't helium or curium, you might as well bury him. So just a little joke to end on. And as always, there is too much unknown in the universe to take a break from learning. Get out there and question everything.